This is problem number 6 from section 4.7. In this problem, they say solve the rational inequality. Now, this is a little different inequality than what we had before with the polynomial inequalities. When you have a rational inequality, you run into that issue of extraneous solutions where you really got to watch yourself from multiplying like this x minus 4 across the inequality to the other side. Especially because you'll notice that we have 0 over there. So if we multiply by x minus 4, it just cancels the x minus 4 completely out of the equation and actually kind of gets rid of one of our possible solutions. So anytime you have a rational inequality, we're going to use a different method to solve this. So this rational inequality is already set up with p of x over q of x, where p of x and q of x are polynomials. So there's actually a nice little theorem, or a nice little theorem formula that we can use to solve these. Because they're both polynomials, we can actually take the numerator, set it equal to 0. So we can say p of x equal to 0. So set p of x equal to 0, and then solve. Set p of x equal to 0 and solve. And then we can also do the same thing with the denominator, set q of x equal to 0 and solve. And these numbers we get, so the solutions we get are boundary numbers. Boundary numbers meaning basically like the roots, all right? So here's what we're going to do first. We're going to say x plus 5 squared equals 0. We're going to solve this by square rooting each side, so we get square root of x plus 5 squared equals square root of 0. So that just gives you x plus 5 then equals 0. Subtract the 5, we get x equal negative 5. Okay, so that's one boundary number. Now we're going to set the bottom x minus 4 equal to 0. Add the 4 over and we get x equals 4. That's another boundary number. Then what we do is we say, okay, let's mark this on a number line. Negative 5 and 4. And we're going to test some numbers here in between these different sections. So we're going to test negative 10, I'll pick because it's left of negative 5. I'm going to pick 0, and then I'll also pick 10 out here. And I'm going to take that this part of the inequality, plug that in the calculator, and I'm going to see when I plug these numbers in, do I get something less than or equal to 0? And that's going to help us find our solution set. So it's fairly similar to just a normal polynomial inequality, except for we got to set the numerator equal to 0 and the denominator equal to 0 because we don't want to multiply by x minus 4 to the other side, which is kind of the way that you would solve a normal equation. All right, so we're going to say negative 10, store it as x, and then I'm going to put in a fraction, which is x plus 5 squared over x minus 4. Enter. Notice I get a negative number, negative 25 over 14. That negative number is less than 0. So my solutions are going to be to the left of this so far. So I'm going to go ahead and mark this with a bracket because it says less than or equal to. And this is negative infinity out here. Now I'm going to plug 0 in. So we're going to have 0 stored as x. Grab that equation again. and we get negative 25 over 4. So we still get a negative number, so actually anything in here works too. So I'm going to go ahead and bracket this. And then finally I'm going to take 10 and I'm going to store it as x. And then grab that equation. And I get a positive number, and a positive number is not less than 0. So anything out here does not work. Well, you'll notice that it works from negative infinity to negative 5 and then from negative 5 to 4. So it actually works from negative infinity all the way to 4. So our solutions here run from negative infinity all the way to 4 with a bracket on the 4. And that's how you solve a rational inequality. You set the numerator equal to 0, the denominator equal to 0, you find your boundary numbers, draw a number line just like with polynomial inequalities, and test different spots to find your solutions.